Okay, so this is exercise 5 in part 2 of this section. It is an argument. So what we want to do is figure out if it's a valid argument or an invalid argument. Instead of doing a complete truth table, we do the indirect truth table. So we will assume that the argument is invalid. We will assume that this is the kind of argument that can have all true premises and a false conclusion. And then we see if we can make this happen. If we can find values for w, x, y, and z that will make all the premises true and the conclusion false, then we will have proved that it's an invalid argument. But if that task is impossible, if we realize that we can only accomplish the task of making the premises true and the conclusion false at the price of violating some law of logic, then we will know it's a valid argument. So let's follow the implications of this first assumption. We assume that the premises were true and the conclusion is false. Now, in order for a conditional to be false, it's necessary that it should have a true antecedent and a false consequent. So in order for if w, then if x, then z to be false, it is necessary for the antecedent to be true and for the consequent, if x, then z, to be false. Under what circumstances would it happen that if x, then z is false? In order for that to happen, it would be necessary for x to be true and for z to be false. Sorry, it's a little cramped there, but I think you can understand what goes where. All right, so our initial assumption has yielded that w has to be true. So let's make sure that wherever w occurs, we mark it true. Here's one, so we'll put the t here. X is supposed to be true too, so we marked it true here, so we'll do the same over here. And z is supposed to be false, so we'll go look for z and we mark it false. So let's see what follows from this. Let's look at the situation that we have over by, oh, there's another x here that I didn't mark. So that x has to be marked true as well. So let's look at what we have over here. We're trying to make this first premise true. W is true, so it had better be the case that if x then y is true, because if it was false, then this would ruin the truth of the whole conditional if w then if x then y. Just imagine that this were false. If that was the case, then this conditional could no longer be true, right? So we desperately need if x then y to be true. It has to be true. So let's make it true. And in order for that to happen, it would be necessary for y to be true. Okay, so now we have all the values for all the letters. W, true, x, true, z, false, and we just discovered y has to be true. So we'll report it here as well. And over here, let's look at if y then z. Y is true, z is false, so if y then z must be false. All right, so we found all the values for all the letters. Now let's see if we can figure out if this is a valid or invalid argument. We assigned true to w, true to x, true to y, and false to z. Is there any violation of the initial assumptions? That is, Are the premises all true with no violations of the laws of logic? Or is there a problem anywhere? I think you can probably see that there's a problem here. This was supposed to be a true second premise, but we ended up with a situation where y is true, z is false, so if y then z is false. But now this conditional that was supposed to be true is actually false because it has a true antecedent and a false consequent. So we found a contradiction. This means that it's impossible to make all the premises true and the conclusion false. We tried, but we only succeeded at the price of violating some important law of logic. So that means that it cannot be done. We cannot make all the premises true and the conclusion false. So this is a valid argument. I hope this makes sense. Let me know if you have any questions.